What we're going to do is we're going to look at logarithms and financial math. The first equation that we're going to look at is the compound formula, and then next time we'll look at the continuous compound formula. So for example 1, we did this in the last unit, but we're going to do a quick review. We have a student, and this student invests $1,000. And they have a bond at a rate of 6%, so we write it as a decimal. And it's compounded quarterly. That means 4 times a year. And so if you remember, we put the 4 back in for the n in both of the equations. And it says for 10 years, so that means that it's 4 times 10. When we plug it into the calculator, make sure that this exponent is not raised to the 4 and then times 10. It's all together, 4 times 10. I like to do 40 just so I don't make a mistake. And that right there is going to give us $1,814.02. Now for the next one, this is when we're going to start moving into logs. What we're going to do is we're going to take the 40,000 and it's equal to the 5,000. And we have the 1 plus 0.11, and it's compounded monthly, so that would be 12, raised to the 12 times, and what we're going to do is we're going to look for t, how long it is. I'm first going to take the 40,000 and divide it by 5,000, and that gives me an 8. Then I'm going to add the 1 plus 0.11 divided by 12, and that gives me 1.0092 raised to the 12t. Now I'm rounding the values, but on my calculator, I'm keeping it exact, and then I round it at the very end. So if you remember from last time, how we get rid of bases is we do logs. So what we're going to do is we're going to do the log of 1.0092. So if you remember change of base formula, what we do is log of 8 divided by log of 1.0092. And that right there gives us 227.89. I'm going to divide it by 12. And once again, I'm using the exact number and then I round at the very end. It ends up being 19 years. So for the next example, this one's a little confusing because we have a rate of 2,500. Notice it earns 500. A lot of students want to set it equal to 500, but the second number should be more than the first if it's an investment that's actually making money. What it's saying is it earns $500. So if you have 2,500 and you earn 500, it ends up being $3,000. Then we have the 1 plus r. It's annually, so that would be 1 raised to the 1 times 3. Now I'm going to divide the 3,000 by the 2,500, and that right there gives me 1.2. And then I have 1 plus r to the 3. Now this is a little bit different. What I'm going to do is I'm going to take the cube root. Now, if you don't remember where the cube root is, another thing that you could do is just raise it to the 1/3. That's the same thing as raising it to the cube root. So when I do that, what I get is 1.0626. Then I'm going to subtract the 1, and that gives me 0.0626. I'm going to turn it into a percent. So that would be 626% or 6.3%. That would be fine also. For example, 4, 6,000 becomes 1,000. Notice there's no adding because it becomes, we're not adding to it. And then what we have is we have 1 plus our rate. It's monthly, and then we keep the 12 to the 10. So I'm going to take the 6,000 divided by 1,000. That gives me 6. I have the 1 plus r over 12 raised to the 120. Once again, if you don't know where the 120th root is, what I recommend is just raising it to the 1 over 120. That seems to be the easiest for most students. And so what that gives you is 1 plus r over 12 is equal to 1.015. I'm going to subtract the 1, and then I'm going to divide it by 12. Sorry, multiply it by 12. And that right there gives me 0.1805, which of course is 18.05%, or 18.1% would also be fine. And for our last one, we have 100,000 becoming 10,000. And we have an interest rate of 8% compounded semi-annually. We're trying to figure out how many years. So I'm going to take the 100,000 divided by the 10,000, and that has 10. And then the 0.08 divided by 2 is 0.04. So I have 1.04. And then we have the 2t. This time what I'm doing is logs because I need to get rid of the base, not an exponent. So if I'm getting rid of an exponent, like the previous one, I'm using exponents to get rid of it. And if I'm trying to get rid of a base, I use logs. So I'm going to do the log base 1.04, the log of 1.04. That cancels. What I get is 2t is equal to, and I use change of base formula, log of 10 divided by log of 1.04, which is 58.72. And then I divide it by 2, so t is equal to 29.4 years.